of course you won't be able to see me right now. So okay, just a second. Shit, click here to retry. uh, okay, just a second, just a second. I know I have started streaming and you're not able to view me. Mm, okay, just okay. Okay, nice. So this is getting connected. We'll drag this here. Poof. Okay. So now everything is working. Okay. Okay. So what we can do right now is start the stream. Window. No, 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 no. Yes, I can do this. You can. Okay, so yes, we are live now. Just a second. Yes, I can do this. I can do this. Here, go to content. On top, and yeah. So I can look at myself if I'm blocking something. And if I'm actually blocking something, I can move myself ahead. That's how I was setting up the OBS. Okay. Oh, again, I lost it. Just a second. Yes. Yes. So we are live and hopefully it doesn't fail this time. Yeah. So where we left was React fibers. We understood that we cannot render everything at once. So you have to render them in chunks so that it doesn't block anything. And this does not work with Safari, like WebKit if I'm not wrong. So it's okay for now. We are just learning the basics. So let's. So we did make some changes to the tree structure, like the file project structure. So we'll just take a look at that. If I do tree dash dash get ignore, yes. So we have this. Let us see if it works or not. So I will run Python. Let us see if it works. Port 8000, localhost 8000. That doesn't work. And why? Because not all the files are in the same folder. So just index.js, file found. What the fuck are you doing in the file? Just a second. So sources. This. Okay. I sources. We have lib, but we don't have build. So we do have a problem here. So get build index.js. Okay. Control Z. I'll just suspend it. ls build. Okay, there is no file. npm start ls build. Okay, now we have a file there, ls source, to remove source index.js, and then if I just do foreground python yes continue, and then we can just just a second. Okay, nice. So if I reload, yes, now we have this. Cool, cool, cool. So we were on React Fiverr. Hopefully my stream is going good. I can do one thing. I can stats here. We are live. We have 0% of drop rate. Okay, and of course you won't be able to take a look at this because it's hidden from your view. So what I can do right now is, and then I can, okay, cool. So to organize the units of work, we'll need a data structure, a fiber tree. Okay, we'll have one fiber for each element, and each fiber will be a unit of work. Makes sense. Okay, let me show you with an example. Suppose we want to render an element tree like this, which is a pretty much complicated one. Yeah, in the render, we'll create the root fiber and set it in the render. Create the root fiber and set it as the next unit of work. The rest of the work will happen through the perform unit of work function. There we will do three things for each fiber. Add the element to the DOM, create the fibers for the element's children, and select the next unit of work. Okay. One of the goals of this data structure is to make it easy to find the next unit of work. That's why each fiber has a link to its first child, its next sibling, and its parent. Okay, cool. When we finish performing work on a fiber, if it has a child, that fiber will be the next unit of work. Okay, if suppose I finished doing h1, it won't move to h2, it will move to the child if it has a child, so it will move to p. From an example, when we finish working on div fiber, with the next unit of work will be h1 fiber. Okay, if the fiber doesn't have a child, we use the sibling as the next unit of work. Make sense? For example, the P fiber doesn't have a child, so we move to a fiber have to a fiber after finishing it. And if the fiber doesn't have a child nor a sibling, we go to the uncle, the sibling of the parent, like A and H2 fibers from the example. So damn, so it's like first you traverse the tree till full of its depth. Then you look at the same level. If there is a sibling, you render that. If there is no sibling, you move up a level, and then you look at the sibling, another sibling. So it is technically like, how do you know, in order traversal, it's like a depth first search on a tree rather than a breadth first search. Makes sense, yeah. That's why it's a tree. It's a virtual DOM. Nice. Okay, so if the parent doesn't have a sibling, we keep moving up through the parents until we find one with a sibling, or until we reach the root. If we have reached the root, it means we have finished performing all the work for this render. Correct. So that's why this is a tree. Now let's put it into code. First, let's remove this code from the render function. Okay, let's first remove this code. Remove this code from the render. Okay, we just remove this part of shit. Okay, now okay. There's a lot of stuff getting removed. So what it does is, okay, so now I have to make all the changes. So create DOM is a function. Instead of render, there's a create DOM which takes in a fiber. So let's go to that. let us go into DOM. We'll take this, paste this here, do this, so that nothing breaks as of now. So what I can do is this, and then we need a fiber here, and we can change this function name to create DOM. I really don't know. Yeah, create DOM. I really don't know why they use D and small and O and small m, but I prefer it capital. Okay, so we have a DOM fiber dot type. Okay, so we don't have element dot type, we have fiber dot type, and we can do this. What we can do is element. So what I'm currently doing is I turn on the RSA. Okay, I can change this to fiber. It will change everything to fiber. Oh, okay, cool. So it's changed. Fiber dot type is equal to this, const is property key not equal to children. Object dot key is property key not equal to children. But we don't have this right over here. So we remove this recursive call. Okay, cool. And then we have object dot key fiber props. I guess this part is the same. And we don't have container dot append child. We just return the fiber. Damn. I don't know if okay, so if to be honest, I prefer this. So we already have this filtered one, and then we use for each on each of it. So this is properly formatted. Okay. Let me return DOM. Why do we return the DOM? We return this DOM, not the fiber. We return the DOM. Yes. Okay, setting. Okay, to do set next unit of work. So now we take the renderer. We set the next unit of work. So next unit of work has a structure like this. What we can do is so next unit of work is equal to your DOM, which is a container, and we have a prop, which is array of element. Okay. Okay. Then we have function work loop. This you already did, right? Next. You know, because yeah. So now we do perform unit of work. So if not fiber.dom, so if this is null, okay. So what we do is I know this won't be visible, so now this is visible, but I can do this. So this is at t. Yeah. So yes. So next unit of work. This takes in a fiber. So fiber is the next unit of work. Okay. So what I can do it. Fiber. And then what we can say is if not fiber.dom. So if there is no DOM defined, then we have to create a DOM. So fiber is equal to create DOM. And we create a DOM with the fiber inside it. Fiber DOM. So let us see what it does again. Fiber, you get a fiber type. There's no type here though. The fuck is wrong with it? Okay, okay. We have element and container, but we don't have any type here. Do we have some types here? No, we don't have. Also, we have next unit of null, 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 null. We have fiber. Next unit of work. Okay. Okay, so if fiber does not have a DOM, we create a DOM. If fiber dot parent exists, fiber dot parent dot DOM dot okay. So if so, this is not fiber. This is a part of fiber. Okay. So again, you are not able to look at this. So we go the top and then the maybe I can move myself to the right hand side. Well, that'd be good. But then I'm reading this. But just a second. Yeah, I'm cropping myself. Just a second. Why don't they have snap? Okay. So you can never capture this. Okay, cool. So, this one. Am I here now? Yes. But then again, I lost the screen. So just a second. Yeah. Okay. So everything is set now. I guess I'm not blocking that much of the view. Okay. So fuck. Just a second. The thing is, I use OBS in full screen mode. So when I switch to it to the full screen mode, actually, why do I need to do it in a full screen mode? I really don't understand why. Yeah, I can just do this and just stretch it out, stretch it out, stretch it out. Yep. And this is here. What I can again do is okay, so I can go switch to chat and this, but no one is there in the chat. So yeah. Oh, nice. Okay, just a second. It's really useless. Ah. Okay, so no, it's better to close this. Okay. How many frames have I dropped yet? 0%. Nice. So yeah, let's go ahead with the coding part. 500 dot. Okay, so if we have a parent, if we have fiber dot parent or dom dot parent, fiber dot parent, what we do is again fiber dot parent is also fiber. So it's sort of like a tree structure. So everything is a fiber. So fiber dot parent dot dom. Of course, it has a dom. We just created it if it doesn't have, and then we just append child dom, but it is not normal dom. It is fiber dot dom. So what is happening right now? So if okay, I'll explain it to you sometime other. So what is happening here is what we can see is cyber okay, so first we take in a next unit of work, we perform a unit of work, we take in a fiber, we check if the fiber has a DOM or not. If it doesn't have a DOM, we go to this function, we create a DOM for it, of course, and then we return the DOM. So then we do this. If fiber dot parent DOM, then if the parent exists, so if the fibers, there is a parent for the fiber, For root, it won't be there. It would be null. So we won't execute this. Okay. Yeah. Just a second. Sorry for abrupt stop. We are back, hopefully. Yes, so we are back. Okay, so we do have some. Okay, there is a lag. There's no. But we are suffering from drop frame rates. I don't know why. Is it because of the internet? Just a second. Just again. Yeah, so there's a bandwidth issue. If something else is using it, we are dropping. We are having a lag. We are running on low frames per second. I guess that would be an issue. But yeah, we are back. So hopefully, yeah, this will recover. Nice. So okay. Uh, just a second. Maybe this will recover. I don't know. You know what? Let's just move ahead with the stream and hope that it's working out fine. Just yes. So yeah, we do this stuff. Keep track of the DOM node in fiber.dom. Okay, property. New okay, cool. And then we just append. Then for each child, we create a new fiber. Okay, so for const element, let index equal to say previous sibling equal to null. While index is So I can just copy this, but I will copy the code you want to learn. So I am not going to copy the const. And we have elements, if I'm not wrong. Elements. So fiber dot props. This is where TypeScript would be helpful. So since we can define fiber as what do you say, a type, we can get all this autocomplete thing. But maybe it's okay. Let's not rely on autocomplete. Index is equal to 0. Then we have previous sibling is equal to null. Okay, so there is no previous sibling for now. So null. So previous sibling is like parent sibling. Let's see. So while index is less than elements dot index. So what we have is while elements dot index while index is less than elements dot length. While index is less than elements dot length. The fuck. I just close this tab, new. Okay, so if it is less than length, do we require index somewhere? Index. Then but then why are we doing this kind of thing? We are not appending anything to elements. We can replace this by for const element of elements. Hopefully this will work. Yes, this should work. Okay. So we know if this is an array, this should work. So const element is equal to element dot index. I don't want to define that because I've already defined that. But then we are not okay. So index is not getting decremented. Where is this? Okay, if index is equal to 0, if this and then we increase the so so we do require this. Okay, so we do require this. So what I can do is we can do this. Const element elements dot index. If I was able to, we have type, we have props, we have parent, we have dom, we have type, we have props, we have parent, we have dom, we have type, we have props, we have parent, and we have dom. Okay, we do have this element, we have fiber of the parent. So, okay, so perform unit of work takes in a fiber. It checks if it has a DOM element created. If it doesn't have a DOM element created, it creates an element for it, but it did not attach it to the HTML yet. It didn't attach DOM to document or the element to DOM yet. We have just created the object, DOM object. So now we take the fiber parent. So if we check, okay, so if it has a parent, you append the child, the DOM element we just created, to the parent DOM element. Don't attach it to body or root or HTML, attach it to the parent if it has a parent. What if it doesn't have a parent? Okay, if it doesn't have a parent, then we just call render, right? So we will handle that in render hopefully. So yes, then we take the elements. Okay, we take the elements, we take the children. Okay, we set the index to 0. We let previous sibling is equal to null. I don't know what they mean by previous sibling right now, but yeah. So we, on the fly, we take the index, but then let index is equal to 0, right? We define the index here. Okay, cool. So while index is less, so we just take the first children, we create a new fiber for that. Nice. We take the first children, we create a new fiber for that. And then if index is equal to 0, okay, if index is triple equal to 0, okay, makes sense. Fiber dot child is equal to new. Okay, so we are creating the tree on the flag. We are creating the tree. Fiber dot child is equal to new fiber. Okay, so it goes to the child, it creates it, and then it again goes to the child and it creates it. But if the index is not 0, then we add it to the sibling. So else we have previous sibling dot sibling is equal to new fibers. Sibling is equal to new fibers. So what we have is, if it is a child, it is the first child, create a new fiber, go into that. If it is not the first child, it is a second child. So both the children are siblings now. So we have to create it as a sibling. Otherwise, if index is okay. So this is exhaustive, and of course we do this. Of course we do this. Of course, of course, of course. So we have to do this, and we just remove the sibling. So previous sibling is also of type fiber. Okay, and we do index plus plus. So index plus plus. I need to learn about JSTalk. I really love JSTalk. So like I would like to learn about it so that I can define types in JavaScript itself. If fiber dot child, return fiber dot child. Okay, if fiber dot child. The whole point is not incremental. But this is not in the while loop. Is this in the while loop? Hmm. Okay, so this is in the while loop, which makes sense. I was like, where the fuck are they updating it? So we can do this. We can have 7k. Then we just delete it, paste it. Then we just do 7. Okay. Then we just do 7j. We then okay. I really do want to comment some things out. So we'll just take the so if there is no DOM element created for the fiber created, this creates attaches the created DOM element to actual DOM tree under its parents parent node. Okay, Okay, traverses. mm, But fiber has a children, right? It has a children, but that is in props. Fuck, man. The fuck. Are you sure this is what? Like, fiber dot child, is it fiber dot child? Okay, 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 okay. New fiber, so fiber dot child is equal to new fiber. If index is not zero, okay, then we have previous sibling dot sibling is equal to new fiber. But of course, we'll start with the zero with the index. We'll have the first child. First child is always stored in the child. What do you say? It's always stored in the. It's always stored in the. That is always stored in the child. Okay, child key. So the first child is always stored under the child. So it is like the eldest son or eldest daughter. So that is always prioritized. It always stored in the child key. Okay, and for the next of them, it is stored a sibling. So how do you recognize? Okay, so suppose I like my parents are there, so I will be recognized by my mom or my father, but my younger brother would not be recognized by them, he would be recognized by me. That's why we have this here. So we set previous sibling to the eldest child. Okay, okay, and then we increment the index. Makes sense. So we are creating the structure which you just saw over here. This one. So we are just creating the same thing here. So this is sibling. Yeah, see. Yes. So yeah. Okay. So now did we close it? Yes. So we close the. So we exit the while loop, and if there is an eldest child. So if fiber dot child exists, that means there is an eldest child. There are children in general, because if there is one, then it will be child. If there are no siblings, then also there will be a child. But if there are no children, then there won't be any child. So if we have a child, if we have the eldest child, we return it, because we are doing depth first search. So fiber dot child, return this shit. Okay, so return the first eldest child for the next routine, and then okay, so if we return it, but let next fiber is equal to fiber. What the fuck is going on? We're just switching the context. Okay, so fiber dot child, we return it, but then we let next fiber is equal to fiber. But fiber was the current one, current parent. Yeah, okay. So why next fiber? So if it doesn't have a child, so suppose there is a childless parent, then what we say is let the next fiber be the parent, and while the parent exists, so then why we are doing this? Why did we just rename this? Do we require? Will it come back? So why did we just rename this? Okay, so we might require fiber context, of course, because we're doing DFS. We'll keep on popping the stack, and then we'll come on. We'll execute a function on each node. We need to store it. That's why, like, we don't want the fiber to be. So next fiber is equal to, it is mostly like a linked list. So siblings are like linked lists. The tree is like that. Okay, so what I can say is, it is a very weird thing. So we have a parent node, then we have a node down there, then we have all the siblings as linked list. Each again can point to that parent, of course. So, so we can see parent is fiber, yes, and then we want to loop over the fiber. We want to loop over the siblings. Okay, then return the next sibling, return the next sibling, unless and until it is null. So, okay, why? There is a next fiber. It's like traversing a fucking linked list. So, and if next fiber has a sibling, if it has a sibling, then return that sibling. Okay, so vi this, you yank it, you just fuck it. So vi this, you yank it, you just return this. Okay, you return the sibling, and if sibling has children, then you traverse through that. So if there's a childless parent, so suppose I have a son, eldest son or eldest daughter, they don't have a child, but they have a sibling and they have a child. So render them then. Just go and render them. Go to the sibling and then just go render them, because of course, like, of course. So we have next. So this is like a society where age defines your authority, like who gets to go first. Pretty much like real society. Next fiber question for the parent. But then if it has sibling. Okay, 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 okay. So the next fiber does, even if it, well, it will return from here. If it doesn't, it will say that let next fiber be my parent, because since I am the only child, there are no siblings. Okay, and I don't have my own children. Then the authority goes back to my parent, and then they will see if they have siblings. Will go on top till we hit null, like the dead ancestors of the family. From where it all started, yeah. So we do next fiber is equal to next fiber dot parent. Yes. So this is like traverse siblings like linked list, and if sibling does not exists, pass on to the parent fiber. Okay, cool, nice. Oh, so either we return the eldest child, or we return its or we return its parent sibling. Either we return this or we return that. From this node, if we are on this node, we can return this or that, this or that. But we'll return this first. If this is returned first, this is a DFS. So technically, this whole function does DFS starting from here. So so mm, uh, DFS starts from here. Cool. Now we have render and commit phases. So we have another problem here. We're adding a new node to the DOM each time we work on an element. And remember, the browser could interrupt our work before we finish rendering the whole tree. In that case, the user will see an incomplete UI, and we don't want that. Wow. Damn. Okay. So this makes sense. If we render this, and if we just render this and then we block it for some some input, some fetch API, maybe something like that. So we will have incomplete rendering and then it will render and it will be janky. So we need to remove the part that mutates the DOM from here. So we need to remove that part. Okay, so we just remove this shit. Instead, we will keep track of the root of the fiber tree. We call it the work in progress root. So we remove this from here. Of course, we remove this because if we do this, so what I can do is let's not remove this. Uh, remove this because if browser interrupts in between, we get an incomplete rendered UI. Okay, so we have a render element. It works work in progress root. Okay, we just rename this to 35k. So work in progress root, next unit of work is equal to with root. Okay, and let work in progress root is equal to null, because why not? And once we finish all the work, we know it because there isn't a next unit of work. We commit the whole fiber tree to the DOM. We do it in commit root function. Here we recursively append all the nodes to DOM. The far, the far, and the far. So what we just did is we created the DOM. What it does is it just creates a replica of like this. Otherwise you can just okay. We build the DOM, all the elements, we create the tree, and we just we don't keep on building it on the main loop. We build it here whenever it's free, and then okay, so this builds like that. So if I could draw it better, you would have understood it. It's like okay, it makes sense. So suppose you already have some HTML and we have some React components here. We don't want to render it in the main loop. So like we take the first element, then we render it, we like take all its children, and then we keep on rendering it. This will block the main loop. So what we say is okay, this is the HTML. Let browser do its stuff. Whenever it is free, take an element, create its DOM element, and store it in a separate tree. We do this whenever the browser is free, and then we are like, okay, now we have all the DOM created. We just have to append it to the tree, and it's okay if it is blocking. We just append the whole tree like that over. So we do need if next unit of work and with root. so if there is no next unit of work and there is a work in progress root, then we commit to the root, then we commit to the root. Okay, we commit root. So work loop is like we should yield or not. False, we could yield it. Okay, perform unit of work. Now we perform the unit of work. Once we commit the root, now we have reconciliation. So far we have only added stuff to the DOM, but what about updating or deleting nodes? That's what we are going to do now. We need to compare the elements we receive on the render function to the last level. Okay. So we have commit work in progress root dot child, and then we have work in progress root set to null. Why null? Because we are done rendering this shit. Function commit work fiber. So function commit work, and then it takes a fiber. But then if I just look at this, sorry, if fiber doesn't exist, just return. So if the fiber doesn't exist, just return. Else, what I want to do is const dom parent. We create a parent. We append child from dom. Boom, bum, bum, bum. When we call this recursively, again we are doing a recursive call. Just please. So we append the DOM to the parent DOM, then we go on to commit work for fiber.child and fiber.sibling, and then and then we do for one return show yield, okay. And if there is no next unit of work and the web root is there, it is not null, okay, then we can commit it to the root, and root takes a okay, and it does it recursively. So current root is equal to web root, and what the fuck is going on? So we need to save a reference to the last fiber tree we committed to the DOM after we finish the commit. Okay, after we finish the commit, we call it current root. Current root is equal to web root. So Okay, okay. So current features are good. So render is the entry point. Technically, render should be the entry point. So what render does is render just creates the web root, creates a DOM container with all this shit. Okay, and next unit of work is equal to, but it is going to be null, and this is going to be, this is not going to be null. Next unit of work is not going to be null. Then this work loop is getting called because again we are doing this. So when this gets called, there is a deadline if it should yield or not, it should yield or not, should yield or not. Fuck this, if it should yield or not, it should yield or not. So it's like, so this will always also, it gives it a time, does some work, and then it again switches the context in this, so it keeps on building. It keeps on building till here. So the virtual DOM is getting built here. Okay, and then if it checks, it checks if we have next unit of work on web root. Okay, so if we don't have next unit of work, we are done making the virtual DOM. We are done making the virtual DOM. Then we have the work in progress root. It is there. It is not null. That means the render has worked. And then this. So we start committing to the root. Then we go to commit root here, and then we commit the work with weave.root child. We take current root is equal to weave.root. Okay, weave.root is equal to null. And there will be another render call. No, it won't be there because we created the virtual DOM. There will be another render call when we have something like use effect. If we have something like, okay, sorry. So if we have something like use effect, it will take a call to render again. So if it does a call to render again, if it does a call to render again, okay, let's extract the code from performance of work that creates the new fibers to a new reconcile children. Okay, here's the new fiber. So if I'm not wrong, this while loop creates the new fiber, and yeah. So what we did is we we just, okay. So what we did was, what if I do this? No, it's not coming. This is fixed. I guess this is a video. Okay. Okay, so it scrolls through that, so it is some sort of library, but I cannot increase the size of the font here. Okay, cool. So we take this element equals to children. We reconcile children here. So what to do is perform, if I'm not wrong, z next to z. This is z, and then go to 11 down. Reconcile children. We pass in the fiber and the elements. Cool. Z, we take this, do this, delete the shirt, and then we go 14 up, we go function, okay, reconcile children, the fuck, reconcile children, and then we just do this, paste this here, and then we go 23 down, and we go, and then this needs to have fiber, comma, element. But it doesn't return anything, and it is fine because it is not supposed to return anything. But it should have written, right? Like. No, it should not, because this is passed by Okay, so just passes by reference, so we are actually okay. So no, we don't need to do that. Work in progress fiber. Okay. 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 So we can do that. Bam, bam, bam. Go to definition. This was change work in progress fiber. Picture. Okay. Make sense. Working process. Okay, reconcile children. Okay. Here we will reconcile the old fibers with the new elements, with the new elements, with the new elements. Okay. The fuck. The fuck. Okay. So we do require this. Do we? Do require this? If we have conditional, do we require it? Maybe. Okay, so we iterate at same time over the children of the old fiber. Okay, we also iterate. Okay, so we iterate the same time over the old fiber and the array of the elements we want to reconcile. Okay, so let old fiber is equal to web fiber dot alternate. Okay, working process fiber dot alternate, and then side. So if it has an alternate, cool. Okay, so this would be true if both of them are true. So if it has an alternate, good, it should have an alternate, and that alternate should have a child. Okay, not equal to null. And for this to be false, both of them must be false. So if the new DOM, like the DOM tree, the new fiber has certain less elements, it has less nodes, it will still keep on running because we have old fiber. Like initially there used to be a lot more of children. So if anyone is zero, it doesn't matter. So if this is false, this is not false, it will still keep on running. So I'm not wrong, did they just know that they didn't? So let, you know what, I'll just let old fiber is equal to web fiber dot alternate and web fiber dot alternate dot child. So we should have both child and an alternate, and we will loop less old fiber is not equal to. So if that is null, okay, so we need to compare it here. So const same type. Old fiber must exist. Element must exist. An element and old fiber should be of same type. So what are we doing here is, the fuck is wrong? So okay. So if we have same type and both of them exist, so both exist and the type is also same, then we do some update. We update the node. So we don't want to render it. Do we? No, I don't know. And then if it is of and there is no same type, but the element exists. So we have created a new element, and then here we deleted it because old fiber exists but the new one does not exist. Okay, cool. It takes care of all the three cases. Uses keys that make a better reconciliation. For example, it detects when children change places in the element array. Here, React also uses keys that make a better reconciliation. For example, it detects when children change places in the element array. Okay, so okay. So if the previous index was not seen, damn. So for some reason the order got changed. If the order gets changed, it will count it as an update because the type won't match. Element and old fiber did match, but because there was a mismatch in placement, so that will require it to create new node, which is useless. Okay, so we can then create a new fiber. Okay, just a second. So we had this. They removed the new fiber. And the statement, what is the new statement? Okay. Okay, so we did this. Okay, so this is how we update this case. So if we don't have the old fiber for this alternate, then we don't create the so we don't create the DOM because it will be created by create DOM. Focus this. Okay. But then if I'm not trying, what is this looking for? No. Okay. So we were here inside this, and then do this, and okay. So deletions old fiber dot effect tag. Okay, give it deletions dot push. Okay. So paste this crap. Okay, and do this. We will paste it here. And then we go. Okay. So we need an array to keep track of the nodes we want to remove. Okay, we need deletion will equal to. So what we can do is we can do something like this. Mark this with global variable. So if I do, so if I'm suppose if I'm here and if I do this, I just jump to here. Nice. Okay. So I've marked this with global variables. Deletions is equal to this. Delete is equal to null. We want it to be fucking null. Null. Okay. Okay. And then we can go to render. Yes. And then here we can add. Why is it doing the food? Okay, I'm in creation. How do we? Okay, next 9J. Okay, so we have deletion set to deletion without wrong is equal to an empty array. And what we can do is see, I don't know why it isn't still paste mode. Okay, how to exit normal pipe paste mode in Vim. For some reason it is not exiting. So yes. So we do have this, but I might have lost the marking. Maybe, I don't know. Yeah, mark not set. So what we can do is deletions. No, good. No. So okay. Okay. So now we have deletions as null. We have initiated the deletions, and then we are committing the changes to the DOM. We also use the fibers from that array. Uh, Deletions for each commit. Okay. It will just keep on appending. It won't delete it. You have to delete it. Okay. So deletions dot for each execute commit. Oh, okay, how do you commit work? You append child. But then you have to handle here. If it isn't fucking deletion, then you have to handle it here. Okay. To handle the new effect tags. Okay, so we need to handle the effect tags here. Yeah, correct. Okay. But just wait a second. Wait a second. Problem is, okay. So if I just go into curve and then red top, okay, reconcile it here. If I was a child, okay, we go to reconcile. start the LSC, we go to reconcile. Okay, we go to reconcile. We do Z top. We then just look at this shirt over here, and then we go to Control D. And we go to Control D. Of course, I can hop from here to here and then like that. But okay, web fiber dot child is equal to new fiber. Okay, and then fuck you. We don't want to create new here now. That is one thing. Okay, if index is 0, else if element. So else if element. So element must exist. Why is it that though? Why the fuck is it that? Is it possible for an element to not exist? Is it? Okay, yes, if old fiber has. Okay. So we do need to check it here. If, else if, element. Because if there are a lot of conditions, old fiber would keep on iterating over the. Okay, if old fiber is old fiber. If old fiber exists, if I'm not wrong, then old fiber is equal to old fiber dot sibling or sibling. So if why can't we have a switch statement? Okay, if fiber dot effect tag is equal to placement. So it is equal to and fiber dot dom is not equal to none. And and fiber dot dom is not equal to null. Ah! Okay, it is not equal to null. Then we append it. Okay. Okay. Hmm. So we need to update the DOM. So let us take a break for around 10. No. So what I can do is right now. Hmm, so we do have to implement this. Then we have function components. Okay, we'll handle this later, but I guess we can. Okay, so there's actually a lot of thing going on in update DOM, and if it's an update, we update it. We do it this an update DOM function. We compare the props from old fiber to the props of the new fiber. Remove the props that are gone and set the props that are new or changed. Okay, remove all properties. Okay, 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 okay. So what we do is what the fuck? Update DOM. Okay. So we have to do so const. Okay, so is new. Takes the previous and the next function returns the previous. The previous multiple image. So we take is gone. So next so there is no function so remove property object dot keys object dot response for each name now press set new or changed properties. Okay, makes sense. We can directly copy this shed. So I'll explain this. So technically, these are just filters. Is new is gone, and then they just use the filters to update something something. Okay, the fuck is wrong though? Redo. Okay. So we make this global. So I just copy this and if I just gg paste this here, okay, and then you go gg, delete this, bam, ba-dum, ba-bam, ba-dum, and then you do two, and then we around we delete this, okay, undo, and then we undo, and then we control R, and then we just do this, delete this, and then we go to create DOM. So we can also take this, delete this, paste this here, even that, delete this. Again, we can see we can see if we have done something wrong. So we can okay. So is property we can remove this because this is global now. Cool. So this makes sense. Then we can check. Okay, so we have updated DOM. Yes. So much. Remove all properties, set new properties, and then we have some sort of shit here. Okay. And then 7k. Okay. Const is event key dot one special kind of prop that we need to update our event listeners. So if the prop name starts with on prefix, we'll handle them differently. Okay. So is event. So of course we need this. But then create DOM calls update DOM mm, and okay make sense. Create DOM calls and update DOM. Mm, with a DOM. So update DOM text DOM previous props next props. Okay, we can all this that and we purchase this. So these are the filters, okay, and then if it is an event listener, we handle them differently. If the event handler changed, we remove it from the node. Okay. It's new. What the fuck is new? It's new. Okay, it is new. Is new. Is new. Okay, is new and is new. So we filter it if it is an event and if it is sorry. Also again a filter if it is not in the next prompt is new. For each why can't we use is gone? Why can't we use is gone? We remove the on thing. Okay. Okay. Okay, so now we can try this out. Okay. Yes, we have some errors. Special talk on 180, line number 180. Okay. 128. Okay. New fiber is not defined. The fuck 148. So we have to go to reconciliation tab. Fuck is wrong. Okay, so we need to create a new fiber. So we just a second. I need to stop the streaming. Not stop it, but pause it for a moment. Sorry. everyone. Why isn't it starting? Okay. So hello everyone. Sorry, I had to cut the stream in between because I had some call. So I'll just continue it right now. So I'll just continue it. Yes. So we are back. Pakas. So where were we having issues? Should yield is not defined, the fuck is wrong. Okay, yes, we haven't defined a deadline. But then request callback, okay. If we have request callback, if I do this, if I do this, and if I do gx, and if I quit this, if I go to here, okay, and then what does it pass? It passes a callback. The callback function is passed an idle deadline object describing the amount of time available and whether or not the callback has been run because the time period expired. Okay, so the why isn't there an examples? See a complete example in the article. Okay, so where is the complete example? Insert numbers and then yes, decoding quantum filament tachyon emission. Damn, that's something. Okay, okay, and it requires a timeout. It doesn't require a timeout. Does it require a timeout? The fuck is wrong? Does it require a timeout? Okay, so why deadline dot time remaining greater than 0 or the timeout? Okay, run task queue. What the fuck is run task queue? Run task queue is here and it takes in a deadline. Okay, it takes in a deadline and time remaining. So time remaining deadline dot time remaining, and by the fuck is it not? Is it throwing error? Should yield is not defined. Should yield the it's okay. If we paste the fuck save, then I just launch again. We have hello world. 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 And we'll just go into index dot. Let's just go into. Why do we have a 3 here? So remove 3 less L. Basics. Okay, so div style equals to round color greetings. Okay, and then next IRL npm start. Then we can do cat build index.js g We have style, we're going to put agree, we're going to put gay, and then we do Python, start server, we do pass inline style to HTML. Style is below, color blue, color blue, color blue, color blue, so I can do npm start. So what I can do is Microsoft it does not have the style. Okay, playing with inline styles, color blue, font is 6, style is equal to this. Bada boom, bada bam, 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 background, color. Okay, okay, I got it. Maybe. It is because of this. If I do, okay, so I have to. Yeah. Yes, nice. And then I can again say tweeting greetings, and then I can make it a span, and then I can be like motherfucker. But then I can do is black. So now this is working. I'm going to do is Control C, Control C, Control I, Control L, Control C, Control L, less DST. Okay, we will build integrated lip, okay. So we can do now get add everything, get commit uh, creating React from scratch basic version with reconciling implemented. Yes, HT, I think it's there. Okay, cool. Thanks a lot for watching, and now we are done with this.